This course section is about testing React apps. And that might sound confusing. Didn't we test what we build all the time? Of course we did, but this course section will be about automated testing. So about writing code that actually tests our code. Which is quite meta, yes, but it is an important part of writing modern applications. And whilst you could create entire courses about just testing, and that definitely is not the focus of this course, I want to give you an introduction into the world of automated testing with this course section, of course focused on testing React apps and React components. And therefore, in this course section, we are going to explore what exactly testing is and why we do it and how we do it, of course. We are going to understand an important concept called unit tests and what that is. And we're going to get our hands dirty and see examples on how to test React components and the different building blocks of our React applications. So before we get started writing any code, what actually is testing? Well, we did test a lot in this course already. We did a lot of manual testing. So that means that we as a developer write some code to implement a certain feature or fix a certain issue. And then, of course, we preview that application in the browser and we test it there. That's what we do all the time as developers. That's what we did all the time in this course. It's super important because we see what our users will see, and we definitely want to polish that and make sure that this works. And this is not going to go away. But testing the app manually is also error prone, at least if it's the only kind of testing you do. Simply because it's hard to test all possible combinations and scenarios. If you have a very complex React app with a lot of different pages and features, and you then add a new feature, or you change an aspect of an existing feature, you will probably test that change or that new feature, but you're not going to test all the other parts of your application all the time. And therefore, you might change something which breaks some other feature in your app. And since you're not testing everything all the time, that breaking change, that bug, might slip through. And maybe you eventually catch it later, but that's not guaranteed, and you might catch it too late, and it might then cause some extra work. And that's where automated testing steps in. This is not a replacement for manual testing. Manual testing will always be super important, but it's an addition. With automated testing, you write extra code that runs and tests your other code, your main application code. And this might sound super weird, but this is a standard procedure, a standard thing to do in modern development. And the good thing about that is that since you write code that tests your entire application automatically, you can always test everything no matter what you changed, because you will automatically then test your entire application. It doesn't cost you a lot of time to do that. And therefore, you typically write such tests, such automated tests that test the different individual building blocks of your app, but where you then test all those building blocks together whenever you make changes to your code, basically, instead of testing only parts of your app from time to time. And that's therefore very technical, but it allows you to test everything all the time. And combined with manual testing, that allows you to catch errors way earlier, and it allows you to write and ship better code and applications. Now, when we speak about automated testing, it is important to understand that there are different kinds of automated tests which you can have a look at. For example, there are unit tests, And I can already say that those will be super important. But you also have so-called integration tests and end-to-end tests. Now, these are the three main categories of tests which you can write. Unit tests are all about writing tests for the smallest possible units of your application. So for functions, individual functions that you use in your application, or in case of React apps, testing some components independently from the other components in your app. And therefore, projects typically contain a lot of unit tests, since you basically want to test all the units, all the functions and components that make up your application. And hence, this is the most common and important kind of test. And the idea simply is that if you test all the individual units on themselves, the overall application will also work. But to verify that the overall application really works, if you put together all those units, we have integration tests. Here, we test the combination of multiple building blocks, for example, multiple components working together. And projects typically contain a couple of such integration tests, but not as many as you have unit tests. Though, as you will also see throughout this course section, it's not always that easy to differentiate between unit and integration tests when testing React apps, since very often you want to test a component that also uses some other component. But we're going to see that in action throughout this course section. So generally, integration tests are also extremely important, but we have fewer integration tests than we have unit tests. And then we also have end-to-end tests. These are all about testing entire workflows in your application, you could say. Entire scenarios, like logging a user in and then going to a certain page. So these aim to really reproduce what a real human would do with your website. Basically what you would also do with manual testing, just automated. Now, whilst this might sound like the most important test, it definitely is important, and you therefore typically do write some end-to-end tests, but not as many as you have unit and integration tests, because if your unit and integration tests work, you can be pretty sure that your overall application works, and then those unit and integration tests are simply easier to test. They often are quicker to run, and they are more focused, and it's way easier to test all possible scenarios if you test all your units for different scenarios than coming up with all possible scenarios if you look at your app as a whole, which is what you do typically with end-to-end tests. So these are important, but it's basically also what you do manually, and therefore you have fewer of those tests. Now in this course section, since it's an introduction to testing, we will focus on those most important kinds of tests, unit tests, and also to some extent integration tests. But at the end of the module, I will also point you at some other resources which you can check out to dive deeper into React testing if you want to. Now, when you start writing tests, there are two super important questions you have to answer relatively early. And these questions are what you should test and how you should test that. And I don't mean how you should technically test that, so how you make sure that you have some code that is then executed by some other tool. I'll come back to that technical question later. But I mean, which kind of code should you put into your testing code? Now, when it comes to what to test, then as mentioned for unit tests, you want to test the different building blocks that make up your application, and you really want to test small building blocks so that you have small, focused tests that only test one main thing each, so that you really have a lot of focused tests which then also fail for a clear reason, if they do fail, instead of having a few large tests which could fail for all kinds of reasons. Now, regarding the how, You want to test success and error cases that could occur if a user interacts with your application. And you also, of course, want to test some rare but possible scenarios and results. And again, that will become a bit clearer once we start writing some code. But of course, there is another important question. We now have a rough idea of why we need tests, and we know that tests are code that then tests our other code. But where do we write this code and how do we execute this testing code? For this, we need some extra tools and an extra setup. And specifically, we need a tool for running our testing code and for asserting the results. So for determining whether some result can be seen as a success or if a test failed with a given result, we need a tool that does that. And then in a React app, we also need a way of simulating, of rendering our React app and components for those automated tests to then interact with them. So we need to simulate the browser, so to say. Now, for the first part, for running our testing code and asserting the results, we typically use Jest. It's not the only tool for this job, but it's very popular, especially for React, and it's easy to use. Now, for simulating and rendering our components and the React app, we typically use the React testing library these days. And both these tools are already installed and set up for you when you work in a project created with Create React App. Here I got such an example project. You also find this project attached. And in there, we'll have a look at the code later. If we have a look at package.json, we see those testing library packages which are part of this project. And I did not install those. They were part of a newly created React project created with Create React App automatically, out of the box. Now, what we don't see here is Jest. We only see this Jest DOM testing library sub-package, but I can tell you that it's also part of this project just as a dependency of one of those other dependencies, basically. And therefore, in such a brand new project, like the one which you find attached, everything is already set up for you to run your tests. And therefore, that's what we're going to do next. We're going to run our first test and understand how that works. So automated testing is a nice feature. How does it work? As I mentioned, attached to the previous lecture, you found this starting project, which is a standard React project, which I did create with Create React App. Now, I didn't really change the component code too much. I just cleaned up the index.js file a little bit. And I did not delete the app.test.js file, which we did not use up to this point in the course, and the setup.test.js file, because we will need those files now. Now, setup.tests.js, as the name implies, just does some setup work, and we don't need to do anything else in this file. But the app.test.js file is quite interesting. This is a file that contains some testing code, and it is there out of the box. Later in this module, we will also write our own tests from scratch. This is a file which is there to test this app component, because the convention is to name your testing files like your component files just with the word test in the file name, so .test.js as an extension to be precise. And in this app.test.js file, we have this test function, which we execute here, which takes two arguments. The first argument is a description of the test. This is up to you. It helps you identify this test in the testing output, which we'll see in a couple of minutes. And it's especially helpful if you have an app with more than one test, of course. The second argument is a function, an anonymous function, which is defined here, which contains the actual testing code. So that's the code which will be executed once we run our test. And in there, we do a couple of things which we don't fully understand yet, but we will soon understand it. We render the app component in the end with help of that render function imported from the testing library, so from that third-party package. Then we get hold of some element on that virtual screen, so to say, so in that simulated browser, so to say, into which this app is rendered. We get hold of some element in there, and we identify an element by the text that is rendered inside of it. Here we are looking for the text learn React in a case insensitive way. This is a regular expression in case you're wondering. And then we just check if that element actually is in the document. So if it exists in the document, and this test will fail if this element is not found, and it will succeed if it is found. And in app.js, we do have this content here, and we do have this learn React text in this anchor tag. And so if we look for an element with a text of learn React, case insensitive, so casing does not matter, then this test should succeed because such an element clearly exists here. But that's all nice and theory. How do we run this test? For this, we got a script just as we got a script for running the development server. We run the development server so that we as a human can preview our app and interact with it. We run the automated tests to see if those work. And for that, in package.json, we have this test script here. And we can run this test script from inside the terminal. And here I'm using the terminal integrated into Visual Studio Code by running npm test. So just as npm start started the development server, npm test will run our automated tests. And here, if I now hit enter, this will start up the testing, and actually it does not run the tests right now. Instead, we now have to press A to run all the tests it finds, and it will automatically look for files that end with .test.js and then run all the tests that are defined in there with that test function. So in this case, this one test which we have. So if I now run A here, if I press A, you see it executed my tests, and then we get this test output here. We see that it ran one test in total, and that one test passed. I'll come back to the difference between test suites and tests a little bit later. Here we see that it ran one test overall, and that test passed. And here we then see all the tests also. All the tests that passed in this case, with the green check mark next to it. And here we see that description text again, which we entered here. So that is what helps us identify which test succeeded or failed. And for example, if I now go to app.js here, and I remove this text, learn React, and I instead say learn more, you see if I save this, the tests automatically rerun, because by default it watches your files and reruns the tests whenever you save changes. And now you see that we got a failed test here. And if I scroll up, we get more information. We see that this test failed. We see that by that red cross here. And we also get an explanation of why it failed. Unable to find an element with the text learn React. Then we get an output of the actual content which it rendered, where it tried to find that text and where it failed to do so. Of course, that is the content of app.js here. Then we see the testing code and the line that failed, in this case, get by text, that's the line that failed. And that is why that test failed. And now, as a developer, we could either adjust our test if we want to have learn more here, or go back to learn React to make sure that this test passes again. And of course, that's a rather dumb example. It's just a basic example, but that's the idea behind testing and how testing works. Now, of course, we can always quit this testing mode by hitting Control C here, and then our files will not be watched anymore, and we need to restart testing with npm test if we want to do that. So these are the basics. Now let's dive a bit deeper. To dive a bit deeper, let's create a new component in the components folder, which I also created now. And here I'll create a rather straightforward dummy component, which I'll name greeting.js. So that's the file name. And in there, I'll create my component function, greeting, which I'll export here. And in there, I'll just return a div with a h2 tag where I say hello world. And below that, a paragraph where I say, it's good to see you. So of course, just a dummy component with some static output here. No state, no props, nothing fancy for the moment. Now this greeting component, of course, can be used in app.js now. And therefore here, instead of that logo, I'll import greeting from /components greeting. And then here, instead of rendering that header and all that stuff, I'll get rid of that. And I'll instead render greeting, that component. This, of course, implies that our test in app.test.js will now fail, because we won't find any element with a text of learn React anymore. But that's fine, because that was just the starting code anyways, and it's not the code I want here. Instead, for the moment, I'll comment out this test here, because I don't need a test in app.test.js anymore. Instead, I want to now write my own first test for this custom component we added here, the greeting component. And we could write that test in app.test.js and render the greeting component from there, or render the app component. But the convention is to write this test as close as possible to the thing you want to test. So if I want to test the greeting component, and for example, test that it's rendering the correct text, then we should create a separate greeting.test.js file and write our test in there. Now, in here, we write a test by using this test function, which is globally available. You don't need to import it. It's available like this. And then, as we saw, we give this test a description. Now, the text here is up to you, but generally, you want to briefly describe what your test does. And here I want to test whether we have the hello world text on the screen. So of course, that's quite similar to what we tested in app.test.js before, but we will get more fancy later. So here I'll just say it renders hello world as a text. Then we need to add a second argument to this test function, which is an anonymous function, which will contain the actual testing code. Now in here, we typically want to do three things when we write a test. We want to write a test by using the three A's. The first A stands for arrange. We want to set up our test. For example, we want to render the component which we want to test. We can also do additional setup work if it's required. Then we want to act. So we want to do the thing which we want to actually test. For example, if we want to simulate a button click, we want to do that as a second step. It's not something we do here, but it is something that you often will do in some tests, and it is something which we also will do later. Last but not least, we want to assert the results. So we want to have a look at the output that's visible in the browser, for example, and then see if that matches our expectations. So these are our three A's. Translated to this test, if we want to arrange, we want to render the greeting component. And for that, just as in app.js, just as in app.test.js, we want to import the component that we do want to test. So I will import greeting from the sibling greeting.js file. And then we can call render, which you need to import from testing library /React, and you then render your component. And to be precise here, you pass JSX code. So you create your component element, so to say. That's the arrange part. Now we could do more here if more is required, but here that's all we need. Then we want to act. We want to perform the main action that's interesting to us, and here that's basically nothing. Last but not least, we want to assert. And for that, I want to look into that virtual DOM, if you want to call it like this, so that rendered component content. And since I want to test whether hello world is rendered as a text, I want to select an element by that text. And if we find such an element, we know that the test succeeded. If we don't find it, we know that the test failed. For this, we can import screen, which gives us access to this virtual screen, to this virtual DOM, which was rendered, if you want to call it like that. And we can use that screen to then find elements on that screen. Now for this, you got various functions available. You got get functions, find functions, and query functions. The main difference is when these functions throw errors and if they return a promise or not. Get functions will, for example, throw an error if an element is not found. Query functions won't do that. And find functions will return a promise. So there it's enough if an element is eventually on the screen. Here I will get an element by text. So I will use screen get by text. And then here we need to define the text for which we're looking. Now here we can use a regular expression, as it was the case in app-test.js, but you can also just hard-code a string. It's just a little bit less flexible than a regular expression, but if you are looking for a full string as I'm doing it here, then it's absolutely fine. You can also pass a second argument here to get by text and configure if you want an exact match, which is the default, or not. If you say false here, casing won't matter, for example, and it will also match substrings. Now here an exact match is okay though, and since that's the default, we don't need to do anything else. Now get by text will, hopefully, return an element. If it doesn't find an element, it will throw an error. And therefore here I'll then get my hello world element. And now we can make the actual assertion. We can check whether that element exists. For this, we got the globally available expect function, to which we can pass our testing result value, and that can be anything, a number, a string, or like in this case, a DOM node in the end, a HTML element. And then on this result of this expect function, we got various matchers, like this to be in the document function, which checks whether the thing we expect here, the HTML element we expect here, is in the document. You can also check for opposites by adding .not and then your matcher functions, like not to be in the document. If you want this element not to be in the document, though in that case you would have to use the query by text function, since get by text would fail if no element would be found. But that's not what I want to check here anyways. I just want to check if this is in the document. So basically the same test as we had it in app-test.js. And that's now our first dummy test. If we now run npm test again, this will start up the testing again, and now it also does run all these tests out of the box. And you see that we got 2 tests, and actually both failed. Now app-test.js failed because, as we see here, we must at least have one test, and that's an empty file right now. So therefore, to avoid this error, I will delete app-test.js. Now it reruns, but the other test here also fails, because it's unable to find an element with that text hello world. And the reason for that is that here I have an exclamation mark. And I did mention that it looks for an exact match here, out of the box. So we either add exact false here to be a bit more forgiving, in which case this test now passes, as you see, or we look for the exact match by adding the exclamation mark here, in which case it also passes. But this is now how we can write our own first test, even though it's basically the same as before, but we learned how we can generally write our tests, and with that knowledge, we can now dive a bit deeper. Now, with our first custom test written, before we write more tests, let's talk about this test suites versus tests thing. As your application grows, you typically will have dozens or maybe hundreds or thousands of tests. And to organize and group those different tests, you often organize them into different testing suites. For example, all the tests belonging to one feature or one component of your application could be grouped into one testing suite. And you create such a testing suite by using the global describe function. Just like test, that's a globally available function. You also give this two arguments, where the first argument is a description. And this is a description of this category to which your different tests will then belong. And here it could be greeting, like this, or greeting component, to make it clear that we're talking about the tests belonging to the greeting component. Then you have a second argument, which also is an anonymous function here. But in this function, you don't write the testing code itself, but you put your different tests in there. So we cut this test and add it in this function. And now we got one suite with one test. And we can have multiple suites, and we can also have multiple tests per suite. So if I now save this, you see that we still have this description text, but it's grouped below this testing group name, this testing suite name. And you see that we have one testing suite and one test. The same as before, because if we have no explicitly set suite, we get one automatically. But now we do have our own clearly labeled suite, which is a good idea. As your application grows, you definitely want to group your tests like this. Now, this first test which we wrote isn't doing too much useful things. So let's make our component a bit more powerful so that we can test more useful things. And let's say that in this component we have some state which should change if a button is clicked. And if that button is clicked, some text on the screen changes, and we want to test whether that works correctly. So for this, of course, we need to import useState from React, because that is how we can manage state in functional components. And then here we can call useState. And here I'll just name that state changed text and set changed text. And at the beginning, this is false because the text has not changed. But if a button is clicked, the text should change. So here I'll have a button where I say change text. And upon a click on this button, I want to execute a function. So I'll add a function in this component, the change text handler function, in which I'll simply call set change text and set this to true. And it's this change text handler function which will be connected to this onClick prop here on this button, change text handler, like this. Now, of course, we need to do something when that state changes, and therefore I will render this paragraph at the beginning, so we can render it conditionally and check if changed text is false with an exclamation mark here. And if that's the case, then I will render that. Otherwise, if changed text is true, hence no exclamation mark, I'll render changed here in this paragraph. That is some code which we could have here. Now, if I save that, the component changes but our test still passes because the only test we have thus far doesn't care about that change we just made to the component. It just tests whether hello world is still there, and that's definitely the case. But now with that new functionality which we added here, I got at least two ideas on how we could test this component now in addition to the test which we already have. And do you have some ideas as well? Think about that briefly, and then after a couple of seconds, I'll share my ideas with you. The two ideas which I got here are that we can A, test whether we see this text if the state did not change yet, so if the button was not clicked, and if we see this other text here if the button was clicked. Because that's important. When you write tests, you really want to test all possible scenarios. Because otherwise, your tests are not worth that much. Because if you only test one scenario, then you will never notice, or at least not as quickly, if some other scenario fails because of some change. So you want to test all possible scenarios that make sense. So here in this case, I want to write two new tests. And definitely feel free to write at least one of those tests on your own. The test where we test whether we see this text if the button was not clicked. Because we don't know yet how we can click the button virtually, so you won't be able to write that test on your own, but you should be able to write that other test on your own, where you check for this paragraph. Here's a quick pause for you to pause the video and try writing that first test on your own. Thereafter, we'll write both tests together. Were you successful? Let's write that together, and let's start with that first test here. Here I want to test that the component renders, and please note how this reads like a nice sentence. Greeting component renders hello world as a text, greeting component renders something else, and that's how you typically want to name those things, so that test suite name and test name form nice sentences. And here I'll then say renders good to see you if the button was not clicked. So here I'm describing what I'm testing. And this part with the button is of course important because we will then soon write another test where we test the opposite. So here we again want to arrange, act, and assert. Arranging is the same as before. We render greeting. Acting is the same as before. We don't do anything. We don't click the button, so we don't do anything. And then asserting is also quite similar. Here I then want to get my paragraph element or output element, however you want to name it, and I want to get it by text. And we could again match it exactly or just look for good to see you without matching it exactly, and hence I'll set exact here to false. And then my expectation is that this element exists in the DOM, so that I'm able to find an element with that test. Let's remove that second test for now and save this. Now our tests are executed, and we see that we got two tests and both passed, which is our expectation. Now let's write that second test where we want to click that button. Here the expectation is that we render changed if the button was clicked. So we render changed if the button was clicked. And then here we write our testing code. Of course, you can also put that into quotes to make it clearer what's the actual text you're looking for. But that is optional and really just there to help you understand your testing output. Now again, we'll arrange the same way we did it before, but now we also need to act. So I'll add those comments again here to make this easier to understand. Now we need to act. And the act which we want to do is that we want to click that button. Now for this, we can import another feature from another package, which also was installed out of the box from the testing library user event package, to be precise. From there, I want to import user event just like this. So from @testing library user event. User event is an object that helps us trigger user events in this virtual screen. We can simply use user event, and then there we got all these typical events which we can perform, like clicking, double-clicking, hovering, typing into inputs. Here we of course need a click. And click then needs one argument at least. It needs the element on which you want to simulate a click. And in my case, that's of course this button here. Now we can select this button again by text, but we can also select it differently, and to mix things up, I'll show you that alternative. We can again use the screen here and get this element by role. We can get it by role, and button is a role elements can have on the screen. And since I only have one button here, that will give me access to this one button I have here. Of course, you could also again use get by text. There's nothing wrong with that. Now that's the button on which we want to simulate a click. So it's this button element which I pass to user event click. And then we still have the assert step. Here I want to get access to some element by text again. So I'll get by text, and the text I'm now looking for is changed. So I'll copy that, and that will actually be my exact text here. So we can now even remove exact false, but you can also keep it there. And now, of course, we need the actual assertion, which is that we expect output element to be in the document, like before. And if I save that, the tests all execute and all 3 tests passed. And that means that this button click simulation worked and this test passed. And that's how you can test user interaction and state changes here. Now to conclude this, there's one other test we could add here to test another thing that should definitely be the case for this component. And it can be hard to spot it, but maybe you can see it. Which other thing could we test here that could make sense to test? Well, let me show you something. What if I introduce an error as a developer, and I actually do forget to render this first paragraph conditionally, so it's always there? Unfortunately, my tests won't spot this. My tests all succeed, because all the things I test still work out. But if I know that this paragraph should never be visible if we click the button, then of course we also need a test that tests if that paragraph is gone once we click the button. So there is a 4th test which could make sense here. A test where we click the button and then check if the paragraph with this text here is not visible. And definitely try writing this test on your own. Again, after a short pause, we'll write it together. Were you successful? Let's write this test together. And for that here, I'll give that test a description. And I'll say does not render. So greeting component does not render good to see you if the button was clicked. That's my description. And then here in the testing code, I will generally copy the code from that other test where we clicked the button, because I again want to click the button. But then in here, I don't check if we have this changed paragraph, but instead I try to find the element with a text of good to see you, and that should not be an exact match. Now, get by text will fail if an element is not found, and here my expectation is actually that it's not found. So here we should write not to be in the document. But again, since this would throw an error if it's not found, this test could never pass if the element is not found, even though that is what we want. So that's then a reason for using query by text, because that will simply return null if the element is not found. And therefore, actually here I then want to check if output element is null. And for that, we got the toBeNull method here. And you can, of course, look through all the available methods to see what you need for your tests you're writing. So here I want to check if that's null, because that would be my expectation, since I don't want to find this element if the button was clicked. If we now save everything, this test fails as it should, because we have an error in our component. This element with this text should not exist. And now we see that this test fails, and as a developer, we can go to the component code and fix this bug, and make sure that we only render this paragraph if changed text is not true, so what we had before. And if I save this, the tests rerun, and they now all pass. And that's why testing is important, and how we write tests, and how we can also test more than just static components. Now let's continue writing tests, and let's now explore how multiple components can interact with each other, and how we can test that, and how we can work with props and tests. And for this, I'll stick to this very simple component I have here. And what I want to do here is I now want to create a new component, the output component, which does what the name implies. It just outputs something. So this will be a quite straightforward component. And of course, I'm keeping it deliberately simple so that we can explore these basic testing concepts with basic examples. And the idea of this output component, therefore, is just to render a paragraph which outputs props children or props text, depending on how you want to do that. And here I'll say props children. And of course, this is kind of a redundant component, but we could have some extra styles on this paragraph and then use this as kind of a wrapper component, as we also sometimes did it in this course, for example, with that card component, which we had in some projects, if you remember that. So that's the output component, and it does use props. Now here, I got this greeting component, and instead of rendering this paragraph here, I now want to render my output component. And let's see how that could work. For this, in this greeting component file, I'll import output from ./output. And now we can replace paragraph with output, like this and like that here. Now, if I save everything, the nice thing which we'll notice is that the tests simply continue to work. So that's the good thing about render, which we use to render the greeting component. It really renders this entire component tree that is required here. So it renders not just greeting and ignores other components used in that JSX code, but it renders the content of those components, like in this case, the output component as well. And technically, we could therefore call this an integration test, because now more than one unit, more than one component is involved, but especially when dealing with such a wrapper component, which doesn't have its own logic, that's of course not really the right term. Testing the conjunction of these two components together is absolutely fine. And that's why I wanted to show this here. This is not something that forces you to split your tests necessarily. You might want to split them if the output component becomes more complex and also starts managing state. Then you might want to test that separately from the core logic of the greeting component. But since that is not the case here, we definitely can keep the tests we have here in greeting test.js to keep testing as we did before. Now I want to move on to a more complex scenario that we could test, a more complex component. I added this new async component, and you find that component also attached. And the component itself is not that complex. It uses state and it uses useEffect, so that in useEffect we send a HTTP request to this dummy API to fetch some dummy posts. And then these posts are set as state here, and they are rendered out as a list down there. Now, if you would start this development server, you would see something like this, because I don't have any styling, since this is not about the styling at all. But you see that fetching and rendering these dummy posts from this dummy API, JSON placeholder, works. Now that works, and here we are, of course, using some core mechanisms we learned about in this course, especially useEffect for side effects like this. Now we want to write tests for this component because, of course, this is also something which we typically want to test. And there will be a couple of complexities related to that. Now for that, let's first of all add a new file, asynctest.js, sounds like a fitting name. And in there, my tests failed because I have no tests yet. I'll add a new test suite, and I'll name it async component to have that as a wrapper. And then in here, we can write the actual test code. Now I will import the render and screen function from the testing library. So I'll grab that import and add that here as well. And then we want to create a test. We want to write a test where we test whether the posts are being rendered correctly. That could be the first test which we want to write. So here I'll say renders posts. That's my test. Or renders posts if request succeeds. And then here, this is our testing code. We now, of course, want to render this async component. So we should import this async component from this async file here and render it. That's our arrange step. Then we don't really need to act because rendering it is already everything I want to do, since we will then fetch and set posts automatically because of useEffect. So no other step is required. And therefore we can now dive into the assertion. And for that I want to check if some list items were rendered, because I know that if list items were rendered, posts were fetched correctly, because otherwise no list items would have been rendered. So therefore, we can reach out to our screen and now find out if list items were rendered. And there are various ways of getting access. Here, I want to get access by role, because getting access by role will allow me to find out if there are list items on the screen, since list item is a role HTML elements can assume. To find out about all supported roles, I also attached a link with more information on that. So here we could use get by role. However, since I expect to actually have multiple list items, we should use get all by role. Because get by role would fail if we have more than one item with that specified role. So here I want to get all by role, and then the role here is list item. You find that role in that attached document. So that's the role by which I want to select items. And therefore here I hopefully have my list item elements, which will be an array of HTML elements. And the expectation now would be that list item elements, this array is not empty. Because if this array of items is empty, we know that no items were rendered. And that, of course, is not the desired result. So here I want to check that this is not empty, so that it does not have a length of 0. toHalf-length allows us to check the length of an array. And here I only care about the fact that the length is not 0, so this is therefore my expectation. And you will typically be able to express your expectation with different combinations here. I'm going for this expectation here. Now, if I save this and my tests run, however, you will see that this fails. You see that this fails because we're unable to find an accessible element with the role list item. So somehow it fails to get list items. And to understand this error, it is important to understand that getAll by role, just like the query methods you have here, will instantly look for these elements on the screen. But keep in mind that here we are sending a HTTP request, which is an asynchronous action. So therefore, the posts are not there immediately. Instead, this component renders, and initially it renders with an empty array here, with an empty array of posts. So therefore, initially, there are no list items. Then, after this first render cycle, this effect immediately runs, and then this request is sent, and once the response is there, the state is updated, and then this component re-renders, this time with list items. But the initial render cycle does not have list items because there are no posts initially, because fetching that post data takes a couple of milliseconds or seconds. And that's our problem here. With getAll by role, we immediately get all these items on the screen, and initially there are none. Now there is a simple workaround though. Instead of getAll by role, you can use findAll by role. The difference is that findAll by role, or in general, those find queries which you can use instead of the get queries, these queries return a promise. Here you get back a promise. And actually React testing library will basically re-evaluate the screen a couple of times until this succeeds. So therefore now this will then wait for this HTTP request to succeed. For findAll by role, you can also specify a third argument. The second argument allows you to set exact and so on. The third argument is another object where you can set that timeout period. The default here is 1 second. So if your items are not there after 1 second, this would still fail. Here, the default of 1 second should suffice, and now we do fetch those items after 1 second at most. And most importantly, we don't just look at the rendered component immediately, but we wait to see if we can find that item at a later point of time. Now I'm getting some red squiggly lines here because since this returns a promise, we should await this before we work on the result, because the result here is a promise, not an array. Thankfully, your test code can be async. You can add the async keyword here. So put in other words, your test here can actually return a promise, and then Jest, our test runner, will wait for this promise to resolve. So it will wait until your test is really done. And now, therefore, here we should add the await keyword. Now, this here is an array, and now this hopefully succeeds. If I now save this, the test runs again, and now we see that we get this success output here. We are able to successfully render those posts. And now I rerun all my tests by pressing A again, and you see all tests passed here. So this works, but this actually is still not ideal. With help of the find queries, we are able to wait for our data to be rendered. So this generally works, but this is still not ideal here, this test. Why is it not ideal? Because we are sending a HTTP request here. And in this case, we're fetching some data from some API. However, when we run our tests, which we typically do a lot during development, we generally don't want to send HTTP requests to our servers. We don't want to send requests because A, that will cause a lot of network traffic. It will hammer our servers with requests, especially if you have a lot of tests with a lot of requests. And B, if you're not fetching data, but you have some component that sends a post request to a server, your tests might start inserting data into a database, or they might start changing things on the server, because of course you also want to test components and scenarios where such kind of requests are being sent. And that's definitely not something you want to do during testing. You don't want to send requests to servers that start changing things there. So therefore, what we generally want to do when we write tests is we either don't even want to send a real request, or we want to send it to some fake server, some testing server. Both are viable approaches, and I'll go for the approach here where we don't even send a request in the first place. Because there's one super important thing to note. When you write a test, you don't want to test code which you haven't written. So in this case, I don't want to test whether this fetch function works correctly and sends a request. The fetch function was not written by me. It's built into the browser. I rely on the browser vendors to have written that function correctly. So therefore, I don't want to test whether fetch successfully sends a request, technically behind the scenes. I instead want to test if my component behaves correctly depending on the different outcomes of sending a request. So I want to check if my component behaves correctly once I got the response data. I maybe also want to check if my component behaves correctly if I got an error. But I don't want to check whether technically sending this request succeeds. And therefore, we want to replace this fetch function, which is built into the browser, with a so-called mock function, with a dummy function that overrides the built-in function, a dummy function that does what we want and that does not send a real request. So that when our component executes during testing, we use that dummy function, that mock, instead of that real built-in function. That's what I want to do here. Now, how can we replace fetch with a dummy function? This is such a common scenario, not just for fetch, but also for something like working with local storage, for example, where you also don't want to trigger changes in the actual storage. This is such a common scenario that Jest, this testing tool which we're using under the hood, has built-in support for mocking such functions. And it's therefore fairly easy to do. When we arrange our test here in our async test.js file, here I now want to override the built-in fetch function with my own one. And for this I can reach out to the window object, which will be available here. And then there is this fetch method. If I call fetch like this in my component, I am just using that window fetch method. So therefore now we can set window fetch equal to a new function defined by us. And here we can use Jest. This object is globally available in our testing code. It is made available by this tool named Jest, which runs our tests. And Jest, this object, has a couple of utility methods. It has the fn method, for example. And what fn does is it creates a mock function, as you see here. So it creates a dummy function for you. The difference to just creating a function on your own is that this mock function then has some additional features which you can use. And you'll see those features in action in a second. So now I did actually override this built-in fetch function with my own dummy function, only of course in my testing code. Now, since this is created with Jest fn, we can again use this mock function which we have now and call special methods there. Here, even though I'm not getting auto-completion for that, we can call mock resolved value once. What this does is it allows us to set a value this fetch function should resolve to when it's being called. And it should resolve to something that is then used here by our code. So when this fetch function is called here, it should, in our case, resolve to an object that has a JSON method. Because here we are working with that resolved value. In this then block, we work with the resolved value of this function call here, of that promise returned by that function call. And then I'm calling JSON on that resolved value. So this is the resolved value we now want to set here. And therefore, I'll set this to an object here. The object resolved by that promise, which will automatically be returned when you call mock resolved value once here. And then here, I want to make it clear that we have a JSON property. Here, this one, which actually holds a function as a value, so that calling it as a function, as we do it in the component, works. And that will be an async function actually, because JSON returns a new promise. That's the case for the built-in fetch function, and that therefore should be the case for our mocked fetch function. And then here it's up to us which value we want to simulate that should be returned. And here in my case, I actually want to return an array when JSON is called and this promise here resolves, because data here in this case is an array for this API endpoint, for this component, and that's then this array full of posts. And every post should have an ID and a title. And therefore, to simulate the success case here, I want to return an array with at least one post with an ID of P1, let's say, and a title of first post. And now with that code, we are overriding the built-in fetch function with our dummy fetch function, where we set the actual value this promise should return with help of these jest features. And if I now save that all, my tests rerun and they still pass. But now we're simulating this success case here. We're simulating this success case and we're not actually sending a request to the API. And therefore, we're not hammering that API. We're not sending unnecessary requests. We are reducing the amount of network traffic. We also avoid potential problems if the server is down and our tests would fail for that reason, which of course is not something we want. And we can control different outcomes for this fetch function to test different scenarios with our tests here. And that's why in such cases using a mock is not a bad idea.